All right, so 2.10, using the math class. So let's talk about what the math class is and what methods it kind of exposes for us to use. So I'm going to go ahead and open that up. As a short overview, here are the math class methods that we're going to learn how to use. So we've got math.abs, which stands for absolute value. And we give a single argument, a number argument in here, and it will return the absolute value of whatever number we put in there. So let me annotate this. And remember, absolute value just means that it'll give you the number back. So like if x is -1, and if you take the absolute value of -1, it's going to be 1, and then the absolute value of 1 is also 1. So it just takes away the direction and just gives you the magnitude of the number. Okay. And then if we wanted to say calculate a number like x to the second, we could use math.pow. And so the way that we would calculate x to the second is by saying math.pow and then putting the base, which would be x, and then the exponent, which would be 2. Okay, so say x was 3, for instance, this would calculate 3 to the second, which would give us 9. The next one is squirt, which stands for square root, and it gives you the positive square root of whatever number you put in here. So let's say that we give 4 for x. This would give us the square root of 4, which would be 2, right? The positive portion of it would be 2. And then the last one is random, which is going to be a little bit more involved for us to kind of learn how to utilize this in all the different ways that we can. But for now, let's just cover the basic thing that it does. So math.random gives us a double value, so a decimal point value that is greater than or equal to 0.0 and less than 1.0. So that means that we can get 0.0 all the way up to like 0.99999, however decimal points our memory can hold, right? Okay, so that is cool and everything, but usually when we want to generate random numbers, we kind of want whole numbers, so we'll learn how to do that in some of the examples here. But for now, this is kind of like the basic methods that we're going to learn about and what they do. One thing I want to talk about is notice that we are calling these methods on the actual class. So the name of the class is math. Usually we've been seeing how we have to instantiate an object of a class to call these methods, right? But for the math method, these methods are declared as static. So we've seen this word static before, but we haven't really talked about what it means. So now we're finally going to talk about what the heck is static. Okay, so each of these are static methods. And that means they belong to the class. They don't belong to objects of the class. They belong to the entire class. And so that means that when you call them, you're going to call them on the actual class and not the method. So real quickly, do not call, let's say does not, or I guess these methods are not called on objects of the class. But on the class itself. Let me move that so it's not, there we go. Let me put static. Static methods are not called on objects of the class, but on the class itself. So that's why you'll notice it says math.abs, math.pal, math.squirt, math.random. So we don't actually create an object of the math class. We just call the methods. It's basically like accessing a book from a library. I say, I want from the math book in my library to utilize, such and such method, abs, pal, squirt, random. Okay, so let's take a look at some examples. Let's go ahead and I'm going to go ahead and clear my screen. And get my mouse back. There we go. All right, so let's start off with using the math class. And let's take a look at what it has. So it just has kind of like demos of some of the math methods that you can use. It includes, it does include one method that you don't really need to know for the AP exam, which is the cosine. So it just calculates the cosine of a particular number. But it also has absolute value, and it has the power where it takes the base and the exponent. So this kind of like demonstrates some of the methods that I was just talking about. So let's go ahead and run this. And we'll see that this line right here, which says x gets the absolute value of -5, that should give us 5. There that is. And then cosine, the cosine of 0 is 1, but it gives us back the decimal value. That one don't worry about so much. If you don't understand what cosine is, you actually don't need it for the AP exam either. This one, math.pal, so remember this first number is the base, and then the second number is the exponent. So math.pal 10, 2 is going to give us back 10 to the power of 2, which should be 100. And again, these are being returned as doubles, so we're seeing 100.0. And then here's another example where we have 9 as the base, and then 3 as the exponent. So this is cubing 9, so 9 cubed is going to be 729. We get it back as a double, so that's why we have the 0.0. Okay, so again, notice that we are calling this on the class. We are not instantiating a math object. So be sure that when you do your homework assignment, you remember you don't have to create a math object. In fact, you can't. And then you're simply calling these methods on the class itself. Okay, any questions so far? So let's go ahead and look at the next example. Just let me know if you have any questions as I go through. Okay, so now we see that we can call static methods without creating an object. So let's go ahead and, so this is an example of just a different class that has some static methods. So this has nothing to do with the actual math class. This is just kind of demonstrating that if we have static methods, we do not need to create an object of the class to access that static method. So in this case, this rectangle class has a static method called rect equations. So rect equations will go ahead and, that's such a silly name, I'm sorry, rect equations. So what it will do is it'll print out these two lines. The formula for area is L times W, so length times width, and then it prints out the formula for the perimeter, which is 2 times the length plus the width. Okay, so we'll go ahead and print those 2 lines. Everything else, though, that you see in the rectangle class is not a static method. So in order to access area, which is a method that returns an integer, you would need an instance of the class because you have to access a particular instance's width and length in order to calculate the area of that rectangle. This up here is a constructor so that you can construct or instantiate a rectangle. object. And then also the toString method needs to be called on an instance of a rectangle class because again, it needs access to a particular's object width and length. So these methods, for that reason, are not declared as static. So all the methods you see here that are not declared as static need to have access to an object, a rectangle object in this case. So let's go back to the tester class. And so here we see rect equations, my favorite method, being called. And remember, it is a static method. So we call it on the actual class that it lives on. So rectangle.rect equations. And it will go ahead and print out those two lines that we saw. So let's go ahead and run that. Okay, so it does print out those two lines. And then in our comments here, it says you can't call non-static methods without an object. So you can't do this. You can't call area on the actual rectangle class. We're gonna get an error here. So it says, hey, what's going on? Oh wait, sorry. The first, it's giving us an error because we have another area. So let's go ahead and run that, and that should give us a different error. Okay, so it says here, non-static method area cannot, where's the rest of my error here? Oh, here it is. Cannot be referenced from a static context. Now, when I was first programming, this like made no sense to me because I didn't realize that what static meant. In my beginning class didn't really define what static meant. So all that means when you see something like that, you have to think to yourself, oh shoot, non-static means I need an instance of the class. I need an object. And what I'm putting here is actually a class. So I need to instantiate, so what they do here, instantiate an object of that class. Okay, and then I can call it on that object. So let's go ahead and comment out line 13 again. And we're going to uncomment line 17 because now we have an object of the class so that we can call that non-static method area on that object. So now this will actually work. Okay, so now you'll see we create the object, the rectangle object called room with a width of 10 and a length of 13. And I'm not making that up. That's just like what the code says here. So the width gets put in first and the length gets put in second in our constructor. And then when we call area on that rectangle object, it returns width times length. So 10 times 13 is going to be 130. And we see that on the screen because we are printing it out on line 18. Okay, so the major thing to get out of today is the difference between static and non-static. So again, static methods you can call on the class, not on an object. Non-static methods, you need an object. You need to instantiate an object of that class so that you can call it on the object because it needs access to properties or private instance variables to do its job. All right, let's look at the last example. So the last example, I think, is random numbers. Yeah, random numbers. So let's go ahead and just kind of run this code and see how it works first. So it does have a scanner object and it prompts us for a maximum value. So I'm going to put in 100. It goes ahead and it stores it, and then it does some stuff here. So let's see what it's doing. It's first getting a random number in the range 0 up to but not including 1. So remember that math.random gives us some number between 0.0 and 0.99999, oops, 99999, however nines it can hold in memory, okay? And then what it does is it multiplies our maximum value sorry, it multiplies by our maximum value plus 1, and then it gives us a double between 0 and max value exclusive. So down here, it's taking whatever decimal point number and multiplying it by the number we put in, which was 100 plus 1. So let's say that random number was, let's say that the random number it gave us was 0.5. Oops, 0.5. So that means if I multiplied it by my max value times 100, so that would be, or sorry, the max value plus 1, which would be 101. Let's see, what would the result of this be? Let's see, 101 times, so that's just getting half of that, right? So that's going to be 50.5. Oops, 50.5. Okay, and then down here, it casts that number as an integer. So what would 50.5 cast as an integer be? Well, it would just be the whole number component here, right? Because it cuts off the decimal point and everything to the right of it. So in this case, we would get 50. So it looks like up here, they got something close to that, and they got 51. I'm not sure exactly what the random, oh yeah, here's the random number that they got. It was 0.5108876, which is a little bit more complicated than 0.5 that I picked. So basically what this is showing is how you can use math.random to get a random integer. So I think this is not exactly super clear what they're trying to do here, which is why I'm going to do another quick example. So I'm going to go ahead and open up Replete here. And I'm going to go ahead and create a new Replete with Java. And so we are going to demonstrate how to generate a random number on a range that we want. Okay, so generating a random number on some range. Okay, so what if I want to generate a number on the range 0 to 100? And I'm talking about integers, so whole numbers. Integers between 0 and 100. So in that case, the first step is to use that math.random method. Okay, so this we know gives us a double on the range 0.0 up to, but not including 1.0, so like, 0.9999999, whatever, okay? So that's not exactly what we want. First of all, it's not, you annotating on my screen? Very nice drawing. So first of all, that's not what we want because it's not a double, right? And what if we wanted some other range, like starting at 1 or starting at 100? That doesn't really give us a lot of flexibility. So what if we need an integer? Oops. Get back down to that screen. How do I get an integer on some range? So I'm going to call this range, let's generalize this. Instead of 0 to 100, let's say on the range of some minimum up to some maximum. Okay. Let's create a min here. Let's say, well, let's stick with our example. Let's say int min is going to be 0. And then int max is going to be 100. Okay, so that's our range, 0 to 100. now what we want to do is we want to calculate how many values are in this range. So how do we do that? I'm going to say how many is going to be equal to the max minus the min, and then plus 1. So this is going to give us how many numbers are on that range, which is going to be a really, really important thing for our next step. So next step is to actually generate a random integer on the range min to max. And this is how we do it. So we're going to get back an int. So I'm going to put int there. And then I'm going to call my math.random, which again gives us a double back. Gives us a double back on the range 0.0 up to, but not including 1.0. And so what I want to do here is I want to actually cast this as an integer over here. So that's going to cast that as an integer. Now, right now, if I don't do anything to math.random, why is the 1 added? That's because we want to know how many numbers are on this range. So let's pretend, well, actually, let's just use this. If I say 100 minus 0, that's going to give us what? So what's 100 minus 0? 100. Now, how many values are actually in that range? And that might be hard to count off the top of your head, but there's really 101. So let's do something a little bit easier. Let's do the range 0 to 1. So if I say 1 minus 0, that's going to be 1 value, right? That gives us a how many of 1. But really we have 2 values. We have 0 and 1. So that's why we have to add the 1, is in order to get the correct number of values back. Because we want to know how many values are we wanting to generate, basically. And so we have to add 1 in order to get that correct number. Does that make sense? Yeah, sometimes that's a little unclear. Okay, so just kind of remember these steps and go through it, and then it'll click on why we're actually doing this. But this is kind of like an easy way to kind of memorize how to do it. Oh, I forgot to give this a name. So this is going to be our number. Okay, so yeah, so we're going to get a random number. We're going to cast it as an integer. But right now, if we don't do anything to this random number that we get back, remember that this is going to be 0.0 to 0.99999. What happens if I cast any number on this range to an integer? What number will we always get back? 0, yeah, exactly. So we want to do something here to actually make it so that we're getting some other integers back. So what we actually want to do is we want to multiply what we get back from math.random by our how many. Okay, so that's going to make sure that we get a number on the range. So far, it's going to be on the range of 0 to how many we get. But we don't necessarily want that. In this case, we do, because our minimum is 0. But we'll see how we can, how this is a little bit, you know what? Let's just change it. Let's change it to 1 to 100. So right now, if I don't do anything, I'll get 0 up to whatever the value how many is. So in this case right now, it is 100. And I don't want 0 to 100. I want 1 to 100, right? So in that case, I want to add my minimum value to this. So this will give me the range that I want, 1 to 100. So let's change these up here because we changed it. Okay, so let's go ahead and print that out. And we should get a random number between our min and our max, which is 1 and 100. So let's go ahead and print that. So we got 80, and we can do this, a few different times, and we'll get different numbers each time. And we should never get anything less than 1, and we should never get anything more than 100 in this case. Okay, so for now, just kind of like take this formula that I've shown you, just take it and kind of like internalize it, and the more we do it, the more sense it'll make, because it does kind of seem like magic for now if you don't understand what's happening. But I felt like, just giving you kind of like a formula that you can kind of use and run with for your homework would be really important, just starting out. And then try to like pick apart what's going on in this equation, because, I kind of described how, this will give us a double between 0.0 and 0.999. We need to cast it as an integer, right, to get a whole number back. But if we just leave it as is, we're always going to get 0. So we need to multiply it by some factor, and that factor turns out to be how many numbers we want, which is just our max minus the min plus 1. And then if we want to shift that number range so that it's not always 0 to some number, we need to go ahead and add min to it so that the starting point is always the minimum. Okay, so right now it's 10:31, so I'm going to go ahead and stop recording.